Morning. And today's lesson for Honor CP Bio is again on chapter 51, but this is 51.2. So remember, the entire chapter is about why animals behave the way they do. And our first section that we did on 51.1 was on sensory input. All of the reasons why parts of the environment or the effects that the animal goes through as far as what they are inputting, whether it's the sun, whether it's the moon, whether it's other factors, they all affect their behavior. And now we're learning about innate and experience learning in this 51.2. And innate is everything that you would think of as instinctive. And your experience learning is just that. What the environment and your personal experiences as an animal are will affect your behavior. And we've talked about innate. We've already discussed that with sensory input with FAP, or your fixed action pattern, your stimulus response, again from 51.1, and your pheromones. All of those are innate. Those are in your body. The pheromone, when an animal smells another animal in heat, that's instinctive to go ahead and mate. Now, imprinting, again, is that innate piece. And it is common in types of birds. And I had a personal experience with that where I was working at a prep school in Virginia for a number of years before I moved back up into the New England area. And I had a member from the golf team, email me, and I read the email at night and said, "Oh, we found a duck egg out on the golf course and thought we should, bring that to you tomorrow morning because there was no mother duck nearby." And I was thinking, oh, please tell me you don't actually have the egg with you. And so I emailed back. I said, please return the egg. The mother may return for it, or there's a reason why the egg was discarded. But when I came to school the next morning, sure enough, here is the boys' golf team with an egg. They had put it on a heating blanket, and I'm thinking, well, it's probably dead. We can look at it, we can candle the egg, see if there's anything in it living, come back later on today, and I'll let you know, knowing that the egg was anything in it was probably dead. Well, about an hour later, there's a little tapping sounds on the egg, and sure enough, little duck is coming out of the egg, and first thing it sees is me. And where some birds, chickens especially, can't see well when they're first born, ducks can see very well, and whatever they first see that's moving is their mother. And so there was a famous scientist, Lorenz, who did quite a few experiments with geese and ducks, and he did it on purpose to prove that imprinting existed. And I will tell you from my personal experience that Sweet Baby Duck, is what we called her, would not go anywhere without me. I could not go to the bathroom without that duck. We put her in an aquarium, and if I left the room, it started smashing its head on the glass to try to follow Mama with it. So imprinting really does exist. The first thing that some animals see is their mother, regardless of what that mother may be. And then we have spatial and cognitive maps. And the famous scientist for this is one we've already talked about, Tinbergen. And in Tinbergen's case, in this experiment, he did many animal studies. In this one, he did a piece of work with a type of wasp, a digger wasp. And the digger wasp would have like a spatial awareness. It had like landmarks that it would use. And he proved this by setting up a series of pine cones around the digger wasp's nest. And so, of course, they are digger wasps. They dig into the ground, and that's where they have their little nest. And he was able to demonstrate that by just moving a few pine cones, the wasp no longer could find its nest. It had all the landmarks for that. And you probably have seen squirrels burying acorns, etc., and wondering how they're ever going to find them. And it is believed that that's also a spatial component. There's a scent component, but there's also a spatial component as well. They have mapped out where all their little acorns are. And along with that, with your spatial and cognitive maps, they also, if you read the book, that there's birds that they have actually done studies on. Chickadees is one of them, which is very common in New England, where they hide seeds as well, and they are able to go back and find them. I'd like you to take just a moment and go back into Google Classroom And I have short little videos on imprinting and that spatial maps. So just take a moment, go back, take a look at those two. They're very short, and then we'll come back and continue the lesson. So some of our other learning patterns are very familiar if you take psychology. Associative learning is one of those big concepts along with social learning with psychology. And your associative learning is learning by things that have gone either very right or very wrong. So one of the examples is the monarch butterfly. And so monarch butterflies, they migrate from Canada down to Mexico, and they winter over in Mexico. They have one of the longest spans of remaining as an actual butterfly before going into their chrysalis. And if you're lucky enough and you have milkweed nearby you, a milkweed is a very tall weed. It's not particularly attractive. It does have a nice pink flower that comes out for a very short period of time that's quite fragrant, and then it has pods in it. And then the pods come in the fall, and they burst open, and all of these flying little seeds go everywhere. And the reason it's called milkweed is if you break that open, there's this milky substance that's very sticky inside. And if you touch it to your tongue, it's extremely bitter. And so what happens is butterflies generally will lay their eggs on the food source for the larva or the caterpillar. And with butterflies, you really should call it larva, moths, caterpillar. And so here the larva, when it hatches, can eat all of that milkweed. And the monarch lays their eggs in the underneath of the leaf. So if you see the milkweed and you see it half eaten all the leaves, just start looking underneath the leaf to see if you can find that larva. But the monarch butterfly only laying their eggs on milkweed, what happens is the larva absorbs that very bitter taste to it. And so what happens is that if a bird sees that larva and goes to pick it off as a nice meal, what they get is a very, very bitter taste to that. And so the bird quickly associates that taste with that particular colored bright orange butterfly. And so that helps save the population of the monarchs. Birds tend to stay away from that after they've had their first really nasty experience of that. But on top of that, other insects that have a very similar appearance get the benefit of that associative behavior. So the viceroy butterfly looks very, very similar to the monarch, and is also generally population is pretty high because birds leave that alone after their experience with the monarch butterfly. And then you have other associative learning. Pavlov's dog, the classical conditioning, is another example where the dogs, Pavlov as a scientist was really rather I don't agree with his practices. They were, quite a while ago. But he actually surgically implanted tubing so that the salivary glands of the dogs, the fluid would drop into his tubing so he could take very accurate studies of that. And so if you've heard of the study, Pavlov's dogs, he actually did quite a few studies, but the one that's most famous as far as psychology is concerned is when he would ring a bell, the dogs would automatically start salivating because he had trained them that when you ring the bell, they're going to get food. Well, in the video I've left for you, he did quite a few studies. It wasn't just ringing the bell, but all of it ends up being classical conditioning where the animal, the poor shepherd, realized that if it was some sort of signal and it was going to get food, so it started salivating. And so again, classical conditioning is part of that associative piece. And then we have cognition and problem solving. And that's really the awareness or the ability to reason, recognizing situations where you can solve a situation. And the video I've given to you is rather strange. It has to do with a pigeon, something that as far as birds are concerned is pigeons are actually known as being quite intelligent. Crows even more so. Crows will hunt in groups. They're called rookeries. But the other examples of that problem solving the example they gave you in the book is a very strange one. I was going to say weird, and I shouldn't, but they have a Y maze, which is very, very classical as far as problem solving, and they put bees in it and are giving them a food source based on of the maze, and the bees do learn what it's going to look like to be able to get their food. Another one example would be chimpanzees that have been well documented as being able to solve problems and using tools. If there are something that they want to eat and it is embedded in a tree or under a rock and they can't move it, they will use a stick or other device. They problem solve. They figure out how to do it. And there are other studies with something as simple as raccoons. I think I gave you a video of raccoons also, where they problem solve, where they put a food source in a tube and the raccoon has to figure out how to get that out. And so take a moment and look at those two videos that I gave you, one on associative or classical conditioning and one on problem solving. They're really kind of interesting to see. Our last two pieces of innate or experienced learning are learned behavior and social learning. So that learned behavior is something that takes a period of time. And so the textbook gives probably the best example in that songbirds, and that they do not know their songs of their species the day that they're hatched, or even week or two. In fact, right now I have outside of the cottage, I've had my second set of flycatcher birds. They're called Phoebe flycatchers. They've actually had 2 sets of eggs this year. And I'm listening as I sit out on the porch to the babies chirping away for food and thinking how long it will actually be before they can do their own species type song. So it's gradual, and they actually can tell, an ornithologist, a person that studies birds, can tell the age of a bird by how far along they are learning their song. So I found that very interesting. It's a learned behavior. And then with social learning, it's observation. I think I show you a video, and I have many of them, and so I've already uploaded those videos, so I'm not sure which one I chose, but I think it was with the chimpanzees and nut cracking, because that is probably one that is the more common, in that they've actually witnessed chimpanzees watching each other, which rock is better. And then once one of them will go away and leave their rock, somebody else will come in and snatch the best rock for the nut cracking, because they've watched which is the superior set of rocks. And so they discard their own and go after what has been left behind. So now to go over this as one large overview, that innate is things that are instinctive. And so, learning itself is modification of behavior, and that's a combination of both nature itself and nurturing. And so many studies have been done that it's a combination of both. So twin studies, for example, have shown that when twins were separated at birth and given 2 different environments to grow up in, they have 2 different views of the world and 2 different sets of experiences. Even though we know if they were brought up in the same family, if we have family members, we know many of them are very different from each other. And I think probably one of the best examples of experiences in the chapter at the very beginning is another Tinbergen study, where he did cross-fostering, where he took different types of mice. One very, very aggressive species of mouse, the white-footed mouse, is not good as far as parental care, and then they also use the California mouse. And so he cross-fostered them, and what that meant is take some of the babies from one nest and put them in another nest in a controlled environment and observed their behavior. And so the white-footed, which are not good parents, when they were given the California mouse, which is babies, which are known as being very good parents, and they were raised by the not good parents, the California mouse babies ended up not having the best parental care either. So it was a combination of that learned behavior, what they saw from nurturing, which they got very little of, so that they passed that on as well. And that, of course, is what a lot of psychiatrists and sociologists worry about, is that parenting tends to really make an impact on all animals, including ourselves. So make sure you read 51.2, look at the examples. I've added some more on Google Classroom, so take a look at all of them. I did a video for each one of these different pieces. And next will be 51.3.